Did you know that balloons were pioneers in the space race and were the first vehicles used in space exploration? Today, NASA still uses large, unmanned helium balloons to carry payloads and cargo into space environments. Some of the most significant balloon missions from NASA are launched over Antarctica. Antarctic flights are of long duration because of the polar vortex, a persistent low-pressure system that contributes to very little atmospheric change, which helps balloons stay at nearly constant altitudes. When a balloon is floating and moving through the air, there are 4 forces that act upon it, called aerodynamic forces. The basic aerodynamic forces are lift, drag, thrust, and weight. Weight is the force generated by the gravitational attraction of the Earth. The magnitude of this force depends on the mass of the balloon and its payload. For the balloon to float, a force must be generated to overcome weight. This force is called lift. Lift is caused by the buoyancy of the balloon. Buoyancy is an upward force caused by a difference in density between 2 fluids. In the case of a balloon, the 2 fluids are air and helium. Helium is less dense than air. So, air being heavier will exert an upward force on the balloon, causing it to rise. Think of how buoyancy works with water. A jumping diver with less density will encounter the water with a higher density, exerting an upward force of lift and allowing them to float to the surface to experience buoyancy. Once the balloon is floating, it is moved horizontally by the force of thrust. For a balloon, thrust is supplied by blowing wind. Still air in front of the balloon pushes against the balloon and resists movement. This resistant force is called drag. In order for the balloon to move forward, the force of thrust must be greater than the force of drag. To create a neutrally buoyant balloon, the balloon's forces of lift and weight must be balanced. A neutrally buoyant balloon doesn't rise or fall. It stays in place, floating at one level. Launching in early 2024, for example, is NASA's Astros space balloon, carrying a powerful telescope that will observe wavelengths of light that are blocked by Earth's atmosphere, creating high-resolution 3D maps of the distribution and motion of gas in our galaxy. These unique capabilities of the balloons are crucial for the development of new technologies for NASA's future spaceflight missions. Want to experiment? Check out our demonstration video for the first balloon challenge. Additional materials can be found in the Balloon Aerodynamics Challenge 1 and 2 Educator Guide.